Hello everyone, my name is Bodhi Jaman Pranto from North South University of Bangladesh. I and my co-authors, MD Hasibul Alam Ratul, MD Mahidur Rahman, Isra Jahandia, and Mr. Junaid bin Jahid have written this paper titled Performance of Machine Learning Techniques in Anomaly Detection with Basic Feature Selection Strategy. So this presentation has been broken down in the following sections: introduction, overview, dataset and feature selection, training, results, and conclusion. In the introduction section, I will be presenting the problem we are trying to solve. Then I will give a brief overview of what we have done to solve the problem. After that, I will explain the dataset and their feature selection process. Then I will explain the training of machine learning classifiers, followed by the results. And finally, I will end the presentation with conclusion and some future works. So nowadays, internet is probably the most available thing around the world. According to the Internet World Stats, there are around 4.57 billion internet users among 7.7 billion people till 31st December 2019. Online servers are apparently the storehouse of data. Nearly every important information, such as personal, private, or confidential data, are being stored in servers. However, there appears a malicious attack in every 39 seconds, which is why about 1 billion personal records were stolen by hackers in the year of 2018. There are several methods for performing network attacks. Some intrusions are meant to force network shutdown, some are used to interrupt services, and some are for stealing data. A few popular attacks are DOS, DDoS, brute force, man in the middle, and many more. In the year of 2019, the Amazon Web Services encountered a DDoS attack which lasted for around 8 hours and interrupted their services. At the same time, Google Cloud Platform also dealt with several issues. So here comes the concept of intrusion detection systems. An intrusion detection system, on the other hand, monitors the events occurring in a computer system or in a network and analyze them for the signs of intrusions. So after considering the statistics of cyber attacks and its consequences, I and my co-authors were thinking about making the intrusion detection systems more confident to detect skeptical behaviors in network. And as a result, we have devised this research work. So we have chosen machine learning techniques for this purpose because this technique has recently proved itself to be immensely used in several accurate detection works. Moreover, machine learning is one of the most effective inductive learning technique which learns from dataset. For training and testing purposes, we have used initial KDD dataset, which is the most popular dataset for intrusions. So the first purpose of this research is to detect whether an incoming network packet is suspicious or not. So this problem is a binary classification problem. Our models or our classifiers will tell us if a network packet is anomaly or normal. The second purpose is to experiment on correlation-based feature selection strategy to get a competitive performance with existing works. And as a third purpose, we are intending to find the best performing classifier for this regard. So this is the summary of the dataset. The initial KDD dataset has total 25,192 instances, where 11,743 instances are anomaly and 13,449 instances are normal. The training set has 17,634 instances, where 8,238 instances are anomaly and 9,396 instances are normal. On the other hand, the test set has 7,558 total instances, where 3,505 instances are anomaly and the rest are normal. Before selecting the features, there were 41 features, from which 11 important features was selected. So our workflow can be described with this flowchart. This is a common flowchart for machine learning based works. First of all, we have collected the initial KDD dataset from KDD Cup 1999. The dataset was generated for the third International Knowledge Discovery and Data Mining Tool competition in conjunction with KDD 99, the fifth International Conference on Knowledge Discovery and Data Mining. After that, we have pre-processed the dataset to make them suitable to be applied on machine learning algorithms. A normalization was performed to bring the values between 0 and 1, which ultimately tackles the misclassification. After that, a feature selection strategy was applied to get only the important features. We will talk about this step in more details in the next few slides. After selecting the features, the data set was divided into 70/30 ratio, where 70% was for training and 30% was for testing purpose. And then finally, after evaluation, we have recorded the outputs. So for selecting the most important features, we just followed a simple theorem. As we know, machine learning models requires the most unique and new information to perform best. If a feature can be represented by another feature, that means both are providing the same information. Therefore, any one of them can be dropped. So based on this, we calculated the correlation of all the features and dropped one of the two features whose correlation is greater than 0.5. We also calculated the variances and removed those whose variance is lower than 0.5. Because variance lower than 0.5 indicates that most of the instances are nearly constant or not providing much new information. For training and testing, 5 different classifiers were evaluated: decision tree, K-nearest neighbor, random forest, naive Bayes, and logistic regression. A threefold cross-validation was performed on training dataset to tune the hyperparameter of the classifiers. We have also evaluated the ensemble of the 4 base classifiers, where the final output is the majority decision of all the 4 classifiers. So this is the classification report of the classifiers, where accuracy, precision, recall, F1 score, area under the ROC curve, and false alarm rate are the 6 parameters based on what the performances were measured. After considering all the measurement, we can see that random forest performed best. On the right side, there are some existing works where authors have used different methodology for the same objective, but the proposed method surpasses them. So as a conclusion, the random forest classifier of the proposed method performed best. The reason is relatively straightforward and understandable. The random forest of this research was built with 1,400 individual decision trees. Each tree contain arbitrary features and instances. So 1,400 individual independent prediction and their majority voting made the decision more accurate as well as reliable. Besides, the dataset was also quite balanced and had significant instances. So as a future work, we are trying to collect our own dataset for intrusions, and it would be an interesting work when we will use these models on the newly collected dataset to detect intrusions in real time. We are also intending to apply cost-sensitive learning to reduce the false alarm rate further. So thank you everyone for listening to the presentation and your cooperation.